So this lesson is being provided so that any of you who watched the first video explaining the method of titration, who have further questions, maybe can view this video and have some of those questions answered before we meet again, which who knows when that will be. Titrations. So you will remember from earlier in the year that a neutralization reaction involves adding an acid to a base. And since an acid and a base are chemical opposites, they will react to form water, and one of the side products of that reaction is a salt. And so understanding the neutralization reaction is fundamental to making sense of an acid-base titration, which, by the way, is the topic of your lab exam. Do I have your attention now? So in case you've forgotten, an acid-base, or well, any neutralization reaction will always involve the switching of your anion and your cation. So essentially, it's just a subdivision of a double displacement reaction. So my magnesium cation is going to react with my chloride anion, and the crossover rule allows us to come up with my MgCl2. My H plus ion will react with the hydroxide ion to form my water, H2O. So we're going to use our knowledge of neutralization reactions and apply that to something that is useful to us. So we're going to take that process and apply it to a process called titration. And titration reaction will allow us to do some math with this and to figure out the concentration of some solutions that we don't know. So here's the basic setup. We'll use our ring stand and our ring clamp. We're actually going to use a burette clamp as opposed to this ring clamp that they're using here, the test tube clamp. But I'll show that to you in class. So here we have this burette, and in the video they showed how it has graduations, and that'll allow us to be pretty precise about the volume of our titrant that we add. So for us, our titrant will be some sodium hydroxide, some base. We have a stopcock here, and the stopcock will allow us to control very precisely the volume of titrant that we're adding. And down here we're going to have our acid, our titrand, that's what's receiving the titrant. And we're also going to add an indicator to that. Our indicator will be phenolphthalein, and that will change our solution from a clear colorless solution to a faint pink at an endpoint. So here's a nice formal definition for a titration. So titration is an analytical method. We're analyzing a solution. And the point of it is to find out the concentration of a solution when we don't know the concentration of that solution. So we have to rely on the use of that indicator that's going to change color when ideally, that's the intent, when the solution is then neutralized. The change in color itself is called an equivalence point here, or an endpoint rather. So I'm going to write that in actually. And we hope that that happens at the point where the acid and the base have neutralized each other. So where the moles of hydroxide and hydrogen ions are equivalent, hence the equivalence point. So let me say that again. So the change in color is called the endpoint. The point where the moles of hydroxide and are expected to be equivalent to that of my hydrogen ions is called the equivalence point. Now, they can be different, and I'll get to that in a little bit. Ideally, we want those to be at the same point, but they can be different. A couple more terms that you'll need to understand before we move on as well are titrand and titrant. So the titrand is basically the solution that is going to be receiving the other solution. So it's the solution that you're looking to find the concentration of. So the purpose of the whole titration is to figure out the concentration of this unknown. right? And so the Titrand is going to be placed in the Erlenmeyer flask. The Titrent, on the other hand, we know its concentration. In our case, the Titrent is going to be that base, and we know its concentration. It's going to be added to the Titrand. So again, Titrent up here, Titrand down here. All right, so let me break down the method for you. So imagine that you, and normally in class I would be demonstrating this, but so bear with me. Normally we would start out with an acid and a base, and the base whose concentration we know, we would sort of deal with that secondly. The first thing you want to do is you want to take 20-25 mils of acid in an Erlenmeyer flask, and it's really important that you follow the instructions of your particular lab report, because it may vary even from these values, but you need to know what concentration or what volume of acid that you're actually adding to your Erlenmeyer flask, and you wanted to record that. So you're going to want to be really precise, and so given that, we're going to use the pipette and bulb. And one thing that students often forget to do is to add their indicator, in our case phenolphthalein, to that Erlenmeyer flask. Without adding the indicator, then you're going to be opening the stopcock on the burette and adding more base, adding more base, adding more base without seeing any kind of color change. And so that's going to be problematic, and you'll have to start over. So again, we want to know the value to possibly 1 decimal point in terms of significant digits, maybe even more depending on the accuracy of your pipette. Remember that the validity of your calculations depends on the accuracy and the precision of your measurements done during the titration. So once you've properly cleaned your burette, and I will discuss that a little bit more in class, but just the process of that, you're going to place your base, whose concentration you know, in that burette, and you're going to take a measurement of the initial volume, the volume that you begin at. And so you don't need to fill it all the way up. The first titration you do, you probably want to fill up your entire burette with base. But after that, it's not necessary that you have it starting at the 0 line up here. But you want to definitely record what initial volume you're beginning with. And so you're also going to want to make sure that there aren't any air bubbles in close to your stopcock, because that can influence the amount of base that you think you're adding versus what is actually being added. And again, accuracy and precision is really essential for an effective and a meaningful titration. And so what you're going to do is slowly turning your stopcock on. You're going to add base and swirl your Erlenmeyer at the same time until you have a solution that's going to remain at sort of a very, very light pink, and that pink is going to last around 20 seconds and then sort of fade. That's when you can say that you've reached that endpoint that is probably going to be close to your equivalence point. So at that point during the titration, you're going to have to take a measurement at the bottom of the meniscus of your final volume of base added. And knowing the difference between your initial volume and your final volume will give you the actual volume of base that was added. And that is essential in order to move forward with calculating the concentration of your acid. So remember that we want our endpoint and our equivalence point to be about equal. So that means that we want our solution to be faint pink. If you do your titration and you add too much base, then your solution will be dark pink. At that point, the amount of base in your solution will far exceed the amount of acid, and then you won't have a neutral solution. You'll have a solution that is alkaline in nature. And so you've negated the whole effect of the titration, and you'll have to begin again. All in all, you want to do this 3 times or more just to make sure that you have some precise values to work with in estimating the concentration of your unknown. And that's pretty much it, folks. I just wanted to talk briefly about how phenolphthalein works. So up here I have the molecular structure of phenolphthalein. as it is in its acidic form versus its basic form. And you're not responsible for knowing the molecular structures, but it is interesting, and these are organic compounds, and so you'll understand a little bit more about what's actually being depicted here. But the addition of base to the phenolphthalein molecule actually changes its chemical structure, and so it has just some slight difference in some of these groups that you see here, and just that subtle change shows you the power of molecular structure in creating certain physical and chemical properties, right? So now we see that in its basic form, quite a dark pink color. And so as the titration proceeds, the concentration of this basic form increases. So the number of this particle increases in nature, which is why you see more and more that gradual change in pink color as the pH increases. And that's it, folks. There'll be a second video showing calculations, how to do titration calculations, but I'll post that separately in a short time. You should view that and then attempt some of the titration calculations that will be posted as well.